What is soil liquefaction? How earthquakes turn ground to liquid. Imagine standing on solid ground, only to watch it ripple and behave like water beneath your feet. That terrifying transformation is known as soil liquefaction, a powerful and often misunderstood effect of major earthquakes. Soil liquefaction occurs when loose, water-saturated soils lose their strength and stiffness in response to ground shaking, typically during an earthquake. This phenomenon causes the ground to act like a liquid, undermining the foundations of buildings, bridges, and roads. Entire structures can tilt, sink, or collapse, not because of the quake's direct force, but because the earth beneath them loses its ability to support weight. The science behind it lies in the structure of certain soils, primarily sandy or silty compositions that are loosely packed and saturated with water. Under normal conditions, soil grains rest against each other, creating friction that provides strength. But when seismic waves shake the ground, the water between these grains becomes pressurized. If the shaking is strong and prolonged, the water pressure can rise to the point where it pushes the grains apart. The soil loses contact, loses cohesion, and behaves more like a fluid than a solid. This effect is most severe in flat, low-lying areas near rivers, coastlines, or where the water table is high. Cities built on reclaimed land or river deltas are particularly vulnerable. Famous examples include the 1964 Niigata earthquake in Japan, where entire apartment buildings tipped over intact, and the 1989 Loma Prieta earthquake in California, which caused liquefaction in San Francisco's Marina district. The good news is that soil liquefaction is predictable and, to some extent, preventable. Modern geotechnical surveys help identify areas at risk. Engineering techniques, like soil densification, drainage systems, and deep foundations, can mitigate the danger before disaster strikes. For buildings already in liquefaction-prone zones, retrofitting can provide crucial reinforcement. Understanding soil liquefaction is not just about earthquakes, it's about awareness, preparation, and building safer communities. If we can predict the invisible threats beneath our feet, we can protect everything that stands on them. Have you ever seen the ground behave like liquid? Or do you live in a region at risk of liquefaction? Share your thoughts and experiences below. We want to hear your story.